I'm going to come over here to the side. Sine of B. Is anybody able to shortcut this process yet? Like you can move the 5 automatically to the other side. Then you get your sine of 20, and then you have over A. So sine of B over B, but I moved B over. Then we have to do sine inverse of both sides. So B is equal to. Now here's the weird thing. I'm going to put a big or because this is a 2-caser. But the first one just comes from plain good old-fashioned sine inverse of both sides in degree mode. Did I put you in degree mode? I might have you in radian mode. But don't worry. We're coming. First of all, though, you guys would all just solve this one. Then we're going to talk about why there's an or. So when you solve this, what'd you guys get angle B to be? 34.45. You guys agree? I heard Salma say yeah. Good? Oh, 7.5. Now we're good? Cool. Now, if you were to keep going, you could find angle C pretty quickly. You could find side C, right? And that's what we were talking about yesterday, like just how to use the law of sines. Yesterday was a good one as far as how to use the law of sines. But I asked you guys to draw a picture, and so I get it. You might finish that triangle. That's good. We'll come back to it in just 1 second. But let's go ahead and try to draw this picture. I'm going to get my protractor out. Remember, the goal is for you guys to not have to, that's a ruler, for you guys to not have to do all of this work with protractors and rulers and whatnot. But I think it'll help you as far as visualizing what's going on. So we have 20 degrees. That's a for sure. 20 degrees for sure. Got it. Spit it out. There he is. Okay, now let's get rid of our protractor. Now we need, let's see. If this is angle A, side A would be like over here somewhere. We need a side B first. So I'm going to go ahead and twist my ruler. Let's see, can we make him parallel? That's roughly parallel. All right. Let's go get a side B. And a side B is going to have a length of 5. Let's not do 5 inches. That's going to be too long. Let's do 5 centimeters. Yeah. So let's go ahead and do side B. There we go. And let's make it 5. 1, 2, 3, 4, and 5. Got it. Okay, so then here's 5. Okay. I need to somehow make a triangle with this length, which can be anything I want it to be. C, he's kind of an unknown. C we'll figure out in just a little bit based on what we find from A and B. We have our angle A here. We have our side B here. But what other piece of information do I know besides 20 and 5? Good. I have the length of side A. Length of side A is 3. So I'm going to go ahead and come on down here. I'm going to get my 3. Now, hold on. Even though I have my length of 3, you guys can see it right here, right, with my 3 centimeters? I know it has to connect right here at the end. But here's the question. How do I make a triangle? What do you guys think? Swing out or swing in? Okay, so if I was to swing out, could I swing out and could I make a length of 3? That would make a triangle. Yeah. No, it went a little bit too far. Let me undo just a little bit. I think I should have swung out just a little bit more. It's not going to make a huge difference. But remember, that side C can be anything. That side C isn't determined yet. So I can come out and I can form a side of 3. Now here's the question. When you guys finished solving your triangle, question, what did you get angle C to be? 125 point? Oh, I should have known that from 0.75, huh? Side C, what'd you guys get? 7.16. All in agreement? Perfect. Guess what triangle you found? That one. Because swinging out's the natural way to go. You found this triangle. And he's completely right. So this one right here, let me get a full screen, get a little bit more room. What you guys just found was, okay, if you have an angle of 20, I'm going to try to copy them really quickly. You have an angle of 20, there's a side C, then you have a side B coming up and being 5. And then you have your angle, well, we'll do angles in a second. Then you have your 3 that swung out. Perfect. Here's your ABC. So 7.16 would be there, and then 125.25 would be there, and 34.75 would be there. Does it make sense that he's a little baby acute angle also? Yeah. That he's maybe just a little bit more than the 20? And then that one's like an obtuse, a little bit more than 90. And then could I also come down and then say, okay, well, if this is 5-ish, 7-ish should be a bit longer. Do you guys agree? Okay, makes sense. But do you remember how I asked you a second ago, how should I swing? Swing out or swing in? How can I swing in? Let me zoom back in on the picture. 3 is less than 5, right, guys? If 3 was more than 5, let's say it was 8. I could only swing out 8, and I couldn't swing back, because if I swung back 8, I'd have to pass the 5 to get the 8, and I would just have lost my poor little 20 degrees. As long as A is less than B, as long as A is shorter than B, yes, you can swing out, but did you guys just notice I could have also swung in? Ooh. What if I had swung in instead? There are a couple reasons as to how this works, and I'll show you in just a second. I'm going to get rid of my ruler just so we can see this a little bit more clearly. But here's the idea. When you have this side less than that side, I can swing out and make a triangle, or I can swing in whenever I'm given SSA. Or in this case, literally, it was ASS. I'm just not going to write it because then I might get in trouble. But anyway, coming back. So, what would swinging in look like? You would still have 20, you would still have 5, you would still have 3. So instead of having my triangle go out, it's going to be like a squished one. Wait, so instead of my angle C being big, my angle C is going to be small. And instead of my angle B being small, my angle B is going to be big. But how big? It's going to be 180 minus big. I still need that number. I still need that 34.75. But because of how sine inverse works, sine inverse only gives me the first quadrant angle when there could have been a second quadrant obtuse angle. And the only way to go find that obtuse angle is to know in your head, SSA, sine inverse. I can't just check sine inverse. I can't just use sine inverse. I need to also check 180 minus sine inverse. And we're going to go ahead and write that in our notes as a way of checking for the two cases. When you solve for your missing angle, in this case it was B, by doing sine inverse, the law of sines, the one option or the one extra, watch out, is you don't just do sine inverse. That does solve for you a possible triangle, but you have to check and say, can I swing in? Can 100 minus sine inverse work? And let's see how we know it does work, and then we'll look at a case as to when it didn't work. So if you subtract 180 minus 34.75, I think you get 145.25. Now we have to go ahead and do our whole 180 thing to get angle C, which is going to be a different angle C. So what's 180 minus 20 minus 145.25? Minus that guy and minus the new angle B. Is it 14.75? So now we have a new angle B, which gets us a new angle C, like an alternate angle C. And then we're going to have to go find an alternate side B. Sorry. An alternate side C. You guys, go ahead and keep using your law of sines with the new information now, because you did it with the old information, and that's good. That is a case. I'm going to draw a picture as you guys find me my new side C. This picture is going to have C. 20 degrees. And 3 swinging in. Did you ace it? We have our new triangle. Hopefully, if you guys did it right, C should be kind of small. At least smaller than the 7. Probably smaller than the 5 or the 3. Because he looks kind of small to me. What do you guys get? I heard a few people saying the same thing. Does that look good? A few people are still double checking. Yeah? So here's the hard part with side-side angle or angle side-side. We don't know anything about the third angle, so it could theoretically be more than one option, aka my side could swing theoretically more than one way. So if side A was shorter than B and it met the shortest distance between two lines, it met in a right angle, there'd only be one triangle. So the one way that it could just meet at the shortest, we saw that yesterday, was using what would the height be if we were just to look at H? And we could use 20 degrees, we could use 5, and we could use H, which would be sine of 20 equals H over 5. So there is one special length less than 5 that side A could equal, where there would only be one possible triangle because it would hit only once and it would be too short everywhere else as it swung. Did anybody plug that in yet? 5 sine of 20. We don't need it for these triangles, but just to see what the height or the altitude is. What'd you get? But 3 is longer than 1.71, so it can't just come straight down. It would go too far, so it has to swing, and it can swing out, can swing in. If it was shorter than 1.71, it'd be one of those dangling guys. You get error in your calculator. And if it was longer than 5, it couldn't swing back while still maintaining the 20. It could only swing out. Those are each of my 3 different cases. Let me take Matthew's question, and let's go back in our notes and say, okay, we did this example. We saw a 2-case problem where literally there are 2 different triangles. This one could finish the triangle, or this one. This is a 2-caser. Let's figure out how to finish off the example in our notes from yesterday and then how to go write ourselves something to study like for a quiz or test. Matthew, what's your question, bud? Oh, because remember, we have angle A. We found angle B. So I added those together, the angles in my triangle, which is 165.25. And then all 3 angles of a triangle add up to 180. So 180 minus 20 minus 145.25. And I think 180 minus 65.25. It's making sense in my head, 14.75. But double check my math. Okay, back to our notes, back to our notes, back to our notes. Let's go work this out. So the one we saw yesterday. 22 was way too long to swing in. The first example that we saw, 22 was way too long to swing in. So when we had 42, 12, and 22, 22, he would not make a triangle, not make a triangle. He'd have to make a triangle way over here, and we would have lost the angle that needed to be there. So that's why this would only be one case, one possible triangle done. But as soon as I changed it to 10, as soon as I said, okay, what if A was 10 instead? Now, he can swing out. He's longer than the 8.03, so he's going to be too long coming straight down. He can swing out, but he can also swing in, which is why yesterday I was like, oh, hey, guys, whenever you find an angle, don't just check the angle, but also check 180 minus the angle. And so to finish off this example in our notes, we found a new value for B, so what are we going to have to do for C? Yep, find a new value. So 180 minus 42 minus 126.5. 180 minus 42 minus 126. Yeah, that sounds good. 11.41. And then we're going to have to go find a new side C also. Just real quick, recapping the math. I haven't showed solving side C today at all. So a few of you guys might have gotten lost somewhere along the way. Remember for side C, we put them on top like you see us doing here. You put sine of the other angle. We'll just do 11.41 to be easy. The other option for side, no, we're solving for side C, for angle C. Use the exact one as much as possible. So 10 times sine of 11.41 divided by sine of 42. Anybody have a side C for me? He should be short. He should be little. They can back Tyler up on any of those? Just give me a thumbs up if you're like, yeah, cool. Thank you, thank you, thank you. So 1 possible, the third side was too long. 2 possible, the third side wasn't too long. No possible, calculator says error. So let's go back to our very first example. The one that we haven't actually answered, whether it's a 0 or it's a 1 or it's a 2. And let's just look at the math of our very first example. We found 1, so we know there's at least 1. We know it's not none. There was no error in our calculator. But let's check it and let's say, okay, we don't have a picture. We know that side A is shorter than side B, so maybe it could swing. Maybe that's a thing. Oh, but wait a minute, side B. Oh, we have angle B. Huh. Just getting confusing. Let's just try the math. What did I just write down as far as or? How did we find both ors, guys? Okay. Who was the angle that we found first in this example? A. So I'm going to look for another angle A and say, okay, good job, law of sines. You found me one. Let me go see if the other one could be true. So the other one, 180 minus, what do we get angle A to be in this example? 1. Oh, yeah, he's a tiny guy. 1.82. Okay. So what's the other option for angle A? 178.18? Haha. I can do mental math sometimes. Okay, so you would hope so, huh? I'm a math teacher. Anyway, awkward. Why can I stop and say that's impossible? What's established? That must be true no matter what. The givens in the beginning. What angle do I know has to be in the triangle? 2 something, right? 2 degrees 40. What happens if you add or subtract 245 and 178.18 from 180? You get a negative. If you go looking with the new information saying, yay, I'm getting my second triangle, and then you go to find your angle C, subtracting, you're going to end up with a negative angle? Is that good? No, let's not have negatives in our triangle. That's awkward. But why does that make sense? 178 point something plus 2 point something is going to be more than 180. Can I have more than 180 in a triangle? That's how I know this one only has how many possible? Just 1. So here's the cool thing. You don't have to have a picture. You don't have to visualize or get protractors, rulers, and draw it every time. What's the one thing that we need to do, that we need to add into our notes for the or? 180 minus, basically. So let's get up here into our SSA, okay? And if I were you, I'd grab out a colored pen because that's where we write down important stuff that we need to remember. True? When we're solving SSA, here's the long story short. You're going to need to use sine inverse. Didn't you guys have to use sine inverse on all of these? Right? When you use sine inverse, somewhere you're going to have, now here's the problem. I can't just tell you when you're doing sine inverse to find A, because maybe you're finding B or C. I don't know. Depends on what they gave you. But I can tell you when you're using law of sines and you go to do sine inverse, you must check the or, aka the 180 minus sine inverse. Let's see if it makes sense. SSA, the long story short. If your calculator says error, what are you allowed to do? As long as you plugged it in right. No solution, I'm done. Impossible. So if your calculator says error, 0, done. As long as you plugged it in right. But if your sine inverse gives you an answer, you can go ahead, you can finish with that answer, but what do you need to check? The C or the B or the A, yeah, whoever he is, you need to check the 180 minus. What if it's the other guy? Is it possible? And if for any reason when you go to check the other guy, you get more than 180 degrees when combining, you're in trouble. No, done. But if when you go to check 180 minus, like in the back of our homework spiral example, like in the last one from yesterday, if you go to check 180 minus and there is room for the third angle, it's less than 180 so you can get your other angle, it will be another case and there will be another possible triangle. So at the end of the day, even though we did all these different examples and we started off with a weird, nasty one that you couldn't even really visualize, when you're doing the ambiguous case, when you're doing SSA, the long story short, calculator says error, you're done. You're using sine inverse, cool, that's one solution. Check to see if there's the other. Does that kind of make sense? Okay. Keep your examples close. I know you guys had some SSAs in homework last night or ASSs in homework last night, and you might have not known to check, so you might have to go back and peek. And if the back of the book said something like, if it was an odd and it was like, oh, hey, there are two sets of answers, and you were like, huh? Maybe now it makes sense. There can be two sets of answers, but sometimes there's only one. Matthew, you still have a question?
How would you find the height of that triangle?
The height of this one, I don't think I want to draw the picture too much. Because it's a super awkward picture. I can throw in real quick. Let's do, there we go. It's going to be like super awkward, super tiny. You just have to figure out what you have. So you have angle B, you have side B, you have side A. I guess angle A is over here somewhere. I guess that must be C. All of that just for me to kind of visualize. I'm going to have this be my height. I would do angle B with H and with A. So you could do sine of angle B equals H over little a, and then plug into that. So sine of 2 degrees, 45 minutes equals my unknown over 4.5. Yeah, do you want to plug it in real quick? I'm just curious. That's a really squished triangle. Like, that's barely anything on those sides as far as the two angles. Yeah, 4.5 times sine of, it gets a little rough when you have to do minutes. That sounds about right. What was it? Point? Yeah, that's a tiny triangle. It's just like a, looks like a straight line, basically. Poor little squish guy. All right. All of that to say, whew, finally. Oh, whoa. There's a whole page of notes we didn't get to yesterday. Uh-oh, this is a bad sign. Or is it? Did anybody actually figure out how to use this area formula last night without me teaching anything? Yeah. It's literally a formula you can plug into. Now, it was in the section. It was in the book, too. But it was in the book, too. But let's see how to use it. Let's see how to use it. Area of a triangle, 1/2 base times height. I know, but we don't have the height. Could we figure out the height? Actually, yes. We could. We could draw a little right triangle and say, how high are you? And then we could go here. And we could say, okay, we know how long you are. You're 52. We could actually figure out what this angle is just subtracting from 180 using some geometry. So 180 minus 102 would be 78. We could actually find the height by using a nifty little, let's see, that'd be a sine. Sine of 78 degrees is equal to h over 52. We could find the height if we really wanted to. But remember how I said maybe we could just learn some new formulas instead of doing all the crazy geometry stuff? Yeah. So even though we could find the height, and then we could go ahead and plug into the old school area equals 1/2 base times height. Because the base is 90, the height is what we would find when multiplying 52 times sine of 78. Oh, wait a minute, hold on. What happens if we plug that in? 1/2, base is 90, 52. Hey, what does the formula tell me that I probably should have done anyway? I can take two sides and sine of the included angle. I can take 90 and 52 and the included angle and plug it in my formula. So actually what the formula says is, hey, you can skip all the geometry and just go right there. When you're given side, angle, side, when you're given side, angle, side, you can plug in side, angle, side by saying 1/2 side, side, sine of the angle. Yeah.
Okay, so like, for that formula, it incorporates like an aspect of all three sides and or angles. But like, what if say you had angle A, side A, and then side B? Like you'd still be missing the C part.
Well, you could either set up geometry and try to solve, or you could use law of sines to get the other side you want. Does that make sense? So that's why this area formula is in this section, because it's like if you were given, instead of side, angle, side, if you were given like side, angle, angle, or angle, side, angle, you could use law of sines to find the other guy you want. Yeah. And then plug in. So some of you might just want to go the geometry route and see, my head, that makes sense. I'm just going to do that and not have to memorize new formulas. And some of you are like, no, please. I would rather just memorize that and say, yay, plug in, plug in, plug in, solve. Plug in calculator, get me 2 decimal places, and we're done with section 6.1. Who already has it for me? 2 point? No. Yeah. Should be pretty big, I think. 0.87. Anybody back up, Matthew? I got one head nod, and I have a couple others that are trying to come from behind, but I think we're good. All right. Section 6.1 done. Section 6.2, before I even start it, because I know we only have a few minutes. What I'm about to show you is the first page of the section, which has all the different types or ways of writing the law of cosines. Didn't we do that with the law of sines? We started off with what's the formula, and is there another way of writing it? You can do the A over sine of A, or you can do the sine of A over A. And then we went ahead and did lots of like different triangle examples of solving for the missing stuff when it was straightforward, and then the ones that weren't straightforward. And then we talked about area. Can I show you the law of cosines section really quickly? To end off class, I'm going to have you guys write down the formulas. One version that can be really good for solving for the sides, and one version that can be really good for solving for the angles. I know, I'm coming right back here, but let me just show you what we're doing tomorrow, okay? We're going to do examples of lots of different given stuff solving for stuff. And then we're going to talk about area. Then we're going to be done. Did you see how there wasn't really a page or examples for some weird, crazy, ambiguous, uh-oh, watch out type of problem? Maybe section 6.2 will be easier, except what looks harder? The formulas. So the formulas might be harder, but the examples are easier, which will be nice. And it ends off with another new area formula like, hey, what if you're given side, side, side? So I'm going to have you guys write down these formulas. Let me try to zoom in just a little bit. But some of you are writing the SSS or the SAS, and you're like, so are some of these formulas good sometimes, but not good other times? Law of sines, I like that one. Can't we just keep using that one, just not that ambiguous case, because that was kind of nasty? Just to show you why we need law of cosines, keep writing down the formulas. What if we were given something like A equals 5, B equals 7, and C equals 3? Just to give you a visual. What if you were given side, side, side? Could, here's my question, could you use law of sines? Why not? You don't have an angle. Did you figure that out from 6.1? You've got to have at least one angle, or else we can't set up a pair that's going to be possible to put into a triangle. So this is not just helpful for SSS, it's the only way to solve with SSS. But check it. Couldn't you plug in the SSS? Oh, hey, this is going to be good for missing an angle. Well, multiple angles. And then these formulas, or this variation of the formulas, this side's going to be good for missing sides. So either you're missing angles, probably all of them, because you're given side, 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 or you're missing a side, but you have the other two, and you have at least one angle. Hence the side, 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 or the side angle side. Now, guys, if you start in on section 6.2 tonight, which would be a great idea, you're just plugging and chugging and solving. But wait, how do we get to ABC, the angles? What do you think we're going to have to do to both sides? Not sine inverse, but cosine inverse. And here's the nice thing. With cosine inverse, no need for 180 minus. It just is what it is, and you're done. What? Go team. All right, cool kids. We'll talk about it more tomorrow. We'll do examples tomorrow. But you saw this section should be pretty quick. So go back, 6-1. Make sure it's good. We'll grade it tomorrow. Oh, yes, please. Someone left it. Someone left one. Up here, too, I need to get. Thanks, Priscilla. They get all focused, and then they forget their coffee. Bye, guys. See you later.